We are calculating the surface area of a cone. Now, a cone is a very interesting three-dimensional shape. And for us to really take a look at what's unique about it, when we take a look at the net of a cone, we clearly can see that the base is a circle. But the shape of the cone itself is a little bit strange, and we don't see a rectangle. It's nothing really that we've learned before, and so we actually have to memorize a little bit more in order to find the surface area of the cone. So if we take a look at the cone, it has some specific characteristics. So when we close this cone up, the very tip of the cone is called the vertex. Now if I open it up and I go straight down from the tip to the center of the circle, that line is called the altitude. And just like we've had in pyramids and on parallelograms, we do have a slant height because we can see it doesn't go straight up. And that slant height represents the side or the height of the side. So just like we've seen in some of the previous three-dimensional figures, sometimes what they're going to do is they're not going to give us the slant height. And in order for us to solve this shape and get the surface area, we have to have that slant height because that represents the height of this sort of irregular figure here. So if they do not give me the slant height, but they give me the altitude and I have a radius, I can go back to my Pythagorean theorem and I can calculate that slant height because I can see right there I have a right triangle. And we know that slant height represents the hypotenuse because it's directly across from that right angle. So I put in my Pythagorean theorem of a squared plus b squared equals c squared. I see my a squared is 21, my b squared is 20, so when I square that I get 441 plus 400. When I pull those two together I get 841 equals c squared. Now remember, we don't want c squared, we want c. So the way we reverse out that operation of squaring is by taking the square root. So whatever I do to one side, I have to do to the other side. And we're really lucky today because 841 is actually a perfect square. It equals 29 yards. Now notice that's just a measurement, so it's not 29 yards squared, nothing like that. It's just that dimension. So we know that this slant height is 29 yards. All right, so now that I have the slant height, I can solve for the surface area. And the surface area is always the same regardless of the three-dimensional figure. It's the area of the base plus the area of the body. Now the base is easy. We can see it's a circle, and we know a circle is pi r squared. The area of the body, this is an irregular shape, and you just have to memorize it. So we know it's kind of circular, so that pi makes sense. We can see that there's a radius there, and we can see on all these lines that these are radii. So the radius makes sense. What does that L represent? Well, L represents that slant height, the one that we just calculated here. So you just have to remember that section for the body. So the body is always pi r L. So now we're going to substitute our values in. Well, pi is 3.14. My radius I can see is 20, so I'm going to square it. Pi is 3.14, my radius is 20, and my slant height is 29. First, I have to do my exponent. So I'm going to do 20 squared is 400. I leave everything else the same. When we calculate 3.14 times 20 times 29, we get 1,821 and 2/10. And it's best to use a calculator for this. It's too hard to do it manually. When we calculate 3.14 times 400, we get 1,256. My last step is to pull it all together so that I get my base along with my body. And when I pull it all together, I get 3,077 and 2/10 yards squared, because remember, this is still surface area, and if we have that word area, you have to square it. So that's how you calculate the surface area of a cone. It's not that difficult as long as you remember this pi r L. So give it your best shot. Try to draw your nets if you need to, but I think you'll do well with this. Just have some fun and take some risks.